Okay, so we're going to do the mathematics that is involved. You should have this sheet in front of you. I copied this so that the teacher can give you this copy, so you can write right on the sheet and have the example in your notes. This is very similar to what we did for uniform motion. We're going to think about things like velocity, because you'll notice here I have a dt graph, a displacement time graph. So because I have a displacement time graph, the slope is the velocity. So you'll notice in the first one, I'm asking for the average velocity. So because I'm asking for the average velocity, we're going to do the same thing we did when we dealt with uniform motion, is we're going to join the first point here to the last point and create our line. So now we have that line, we just need to find the slope of that line. That's not too bad. I'm going to find two good points. I'm going to use the first one because it's an excellent point. And then I'm going to use this guy here for me at 11 and 18 because it's a really good point on mine. You might use a different one because maybe you have one that's a bit better. So I'm going to say the slope is going to be 18 minus 2 for my rise, and then my run is 11 minus 0. So there we go. I have my numbers. And then I just have to put them in the calculator. Remember, we're using two sig figs because we can read to 2 digits. It should be actually 2.0. So when I in the calculator, I got 1.45, which rounds to 1.5 meters per second because we are finding the velocity. Okay, so that's our first one. So then we're going to do an instantaneous velocity. Now this might seem a little weird, instantaneous velocity. It means an exact velocity, right? A perfect velocity. But you say, how do I do that using a curved line? Well, you'll notice first of all, it says at 12 seconds. So let's start by finding that point. It's right here is my 12 seconds. And what I want to do is find how sloped is it at this point. Now, you're going to use a ruler to do this. I'm going to use my line tool. But what I want to do is draw a line, and you're going to take your ruler up and put it against the line from the curved side. And we're going to draw what's called a tangent. So basically, it's a line that goes through that point and no other points in the curve. So you'll notice the spacing on this side and the spacing on this side of the line I just drew are the same. I'm going to make my line blue to make it stand out a bit. So I've gone through this point and no other point on the curve. So I found the actual slope of the curve at that point. Now I just need to pick 2 points and find the slope. So I can do that pretty easily, right? I'm going to pick 2 points. I'm going to use this one because it's super easy, right? At 12 and 14 is what that is. And then I'm going to find a second one, and it can be anywhere on the line. This one looks really good on mine. Yours might be really different. Just pick 2 points. Remember, I expect some variation. So I'm going to do that. I'm going to find my slope. So I'm going to determine my slope by finding that number. So I know I'm at 14 and 2 on the top. And then my bottom numbers we found were at 12 and 2. No, I've done the top one wrong. So it should be at 14 and 2 and 12 and what is that? 5? Excellent. So then I just have to do the math. So 14 minus 2 is 12 divided by 7. So that gives me 1.71. So my slope or my speed, my instantaneous speed would be 1.7 meters per second. Remember, you will probably not get the exact same number as me. Don't let that panic you. You just need to be in the right range. You just have to be close.